Welcome to SolderSmoke, a podcast by radio amateurs with a focus on homebrew electronics. From our workshops in Juneau, Alaska and London, England, we get together on the Echolink system to swap ideas about radio construction projects. Our website is www.soldersmoke.com. Please send feedback to soldersmoke, that's one word, @yahoo.com. So, as we step away from our soldering irons and oscilloscopes, please join us for another edition of SolderSmoke.
KL7R, KL7R, M0HBR. Are you there, Mike?
Yeah, M0HBR, KL7R. Good morning, Bill. Been a couple weeks since I've talked to you. How you doing?
Great. Good to hear from you, Mike. Yeah, all is well here in London. It is the 13th of January. It's 07:30 Greenwich Mean Time here on Saturday morning, long weekend, and well, yeah, glad to get back to be able to talk about a little solder smoke. Have you been generating any up there in Alaska? Go ahead.
Well, yeah, I've been doing a little bit. Been playing with oscillators. I think that's probably going to be one of the more painful things I learn here. I'm starting to develop some serious respect for people that have the patience to make oscillators stable and the like there. Just even basic experiments have been painful there. Over.
Oh, I know what you mean. I think my first successful homebrew project was the Michigan Mighty Mite. What a wonderful little QRP rig. I think we should probably make them available and send them off to anybody who expresses an interest in home brewing. Just a little bag of parts. I remember the coil is wound on a 35 millimeter plastic film canister, and man, I built that thing and I struggled with it, and then all of a sudden it started oscillating. I had the receiver on and I fidgeted with some wire. I moved the coil a little bit, and I don't know. I guess to paraphrase the title of a book, I referred to the experience as the joy of oscillation. KL7R, M0HBR.
Well, I don't know if you've ever mentioned the Michigan Mighty Mite before. I've never seen that, so I'd love a schematic. Maybe you could point us all to a schematic there. Well, I've got some oscillation. I told you the last time that I was wrestling with trying to get an NE602, NE612 to oscillate with a crystal oscillator. I'm pretty good with crystal oscillators and VXOs. Go to VFOs, I had real problems. So I decided to go to the standard Hartley with a diode at the gate of the FET and a tapped coil Hartley, and initially I did experiments, like I said, with the laser temperature thermometer, and then I built one with a crystal oscillator. But then I built one with an LC Hartley, and I was doing the same sort of things, trying to get drift down to some reasonable amount, temperature drift, and I pulled out the NPO caps that I got, and built one circuit, and it I tried building it with a variable capacitor, and then I decided to take the variable capacitor out of there, just try to get the just an LC oscillator to be stable, and wound up having to rewind the coil. And so then after a bunch of fiddling around, I found out the thing that I tried boiling the coil like W7ZOI-KL7R suggested, and I didn't see a whole lot of help there. But I'm willing to say that it did help a little bit, although I didn't measure any real change there in a dash. What was it? A T50-6, a yellow core ferrite. I didn't see a whole lot of change there, but I did see a lot of change by flooding the toroid inductor with candle wax. That seemed to really stabilize the thing. It seemed like most of my drift was due to the coil. And I did find out something really interesting about the diode there at the gate there, Bill. M0HBR KL7R.
KL7R M0HBR. We're joined by the third member of the SolderSmoke team. Billy's with me here. It's a little bit later in the morning, so he's still waking up, but he's here. Yeah, well, these are real homebrew SolderSmoke adventures you're describing here, Mike. Boiling coils, the use of candle wax. Excellent. This reminds me of the old, I think it was the 6L6 tubes they were. They used to invert them and put them in cans of oil and water so they could get some more power out of the thing. Yeah, excellent. Well, you know, I haven't really fought this battle too often because almost all the rigs I've been building have been at for 20 meters or 17, and I followed W7ZOI-FP's guidance in those regions and kind of just drop out of the real VFO territory and use variable crystal oscillators and the one variable ceramic oscillator that we described. I do have a real LC VFO oscillator in my 40-meter DSP rig, and I started out trying to build some sort of synthesizer thing where I would have a fixed crystal oscillator mixing with the product of mixing with the output of a VFO operating at lower frequency, and this would get me up to 7 megs. But then I decided that was more trouble than it was worth, and it created a whole bunch of other signals that needed to be suppressed. And so I just decided, let me give it a try and build a real VFO, and I did it, and just using NPO caps and some of the guidance that Doug DeMar put out about how to stabilize a VFO. And I've never measured it. I don't have the laser kitchen technology available in the KL7R laboratories, so I have never measured it. But it drifts a little bit. But I mean, if you've grown up with DX40s and HT37s, you're kind of used to having the thing drift a little bit. so I compensate for it. But it's the drift is you can deal with it. It's not that bad. But now tell us about the diode, KL7R M0HBR.
Well, speaking of synthesizers and what all, there's one thing I wanted to mention. Hans Summers, you really got to get a hold of him and see if he'll be a guest here, because really interesting fellow. I hope you get a chance to write him a note. The one thing I wanted to mention, though, is Hans Summers' site, www.hanssummers.com, is off the air, and it was really frustrating to me because right after, he has the best documentation on huff and puff type VFO stabilization techniques, and I was looking at him, and I was going to crawl around in this VFO stuff, and then I was going to apply one of his 1-chip, 2-chip, or 3-chip VFO huff and puff stabilizers, and I went to look, and his site went off the air just about the first of the year, and I was stressing over that because I hadn't saved his entire site to my hard drive. But I did. After the panic wore off, I went and looked on the GQRP Yahoo group, and he had left messages there that he was in the process of getting a new service provider and had temporarily housed his pages on a temporary server. So if you need to, you can look in the Huff and Puff Yahoo group or the GQRP Yahoo group, and there's notes in there as to where Hans Summers' site is temporarily located till he can get his stuff onto different hardware there. Anyway, the circuit for the Hartley has a resistor and a diode going to ground at the gate of the FET, and the diode is to stabilize the bias and to stabilize the bias and to negatively bias the gate of the FET. Anyway, I'm looking at this thing, and I'm fairly, I guess I must be a little bit picky about the drift. I've got these wonderful solid state synthesized rigs that are effectively crystal controlled. I can put them anywhere I want, and I hear things like drift, and it really bugs me, especially doing PSK and things like that. Or if you're in a QSO with somebody on CW, and by the end of the QSO you've changed pitch by 300 hertz. That's a bad thing, and that was happening to me on one of my rigs. Anyway, I'm tracking the audio pitch as received in my station receiver on an audio spectrum analyzer. Spectrum is the one I use, and so you set it for 700 hertz or something like that, and then you can see as you touch the capacitors or the coil or blow on them, you can see the pitch drift over time. Long integration period time, and it kind of records it. Anyway, so I'm doing this, and I've got this laser culinary laser thermometer where it has a little red laser dot that you shoot at the item you want to measure, and the thermometer measures the temperature at that point. So I'm sitting there, and I'm pointing the dot at the transistor, and my hand jiggled, and the receive frequency jumped all over the place. I said, "What's going on here? Why is this thing jumping out of oscillation, or why is it jumping frequency?" And I took the temperature again, and it jumped again. And then I realized when the laser dot hit the silicon diode, the frequency changed of the VFO of the oscillator. And then I realized this is a photoelectric effect of the laser beam, photons knocking electrons off the diode there and changing the bias point of the transistor. And this is the kind of stuff that Einstein got a Nobel Prize for in 1921, 2 or 3, something like that. They had, in that case, they had charged up a polished zinc plate with electrostatic charge, and then they put a ultraviolet light and pointed it at the charged plate. And then you could see that the charge decayed, and so they had a photoelectric effect. And anyway, he noticed the same thing. It was a moment of discovery. It was kind of fun. I brought my wife in here, and I said, "Hey, you see this? This is really cool. I'm knocking photons. The photons are knocking electrons off this thing. Something you can almost see physically there. M0HDR KL7R."
Yeah. Wow. I'm reminded of the, it's not Elvis is in the house, it's Einstein is in the shack. Yeah. Great. It's interesting. I guess what's happening is you are, I guess when you, maybe think about it this way, maybe I guess the diode is normally reverse biased, and when you hit it with the laser, it's increasing. I guess it's decreasing the size of the depletion zone. That's the way I'm thinking about it, just off the top of my head. And forgive me because it's 7:30 in the morning, so the top of my head might not be too good at this point. But maybe you're affecting the size of the depletion zone between the P and N layers, and in effect turning that thing into a small variable capacitor. I mean, that's how the varicaps work. And so maybe that's a way of doing a new way of controlling the oscillators, Mike, with lasers. we have PTO, permeability tuned oscillators. Now we're going to have culinary laser tuned oscillators. The CLTO, developed by KL7R. Soon, all rigs will have them. Hey, that's great. This might be a good time for me to jump into our laser story, but let me turn it over to you first. KL7R M0HPR.
Oh yeah, I want to hear that. I know you saved it from last time. I guess I've got a page full of stuff I wanted to talk about, but the one other thing I did that would maybe interesting to people is if in a disk drive, in a hard drive on a PC, there's some really strong magnets in there. I think they're made by they're niobium, or they're basically a rare earth magnet in there. And they're so strong that you can use them to hold up the Sunday Times on your refrigerator. Huge magnets. Anyway, got a couple of them out of hard drives, and I used to use them to go fishing for wrenches and stuff that I lost in the bilge of my boat. You tie a string to it, and they'll pull out your crescent wrench from the bilge. Anyway, I had this oscillator running, and I took this magnet. And there's a not a ferrite, but an iron core, a T50-6 coil in here. And I took the magnet and held it a foot away from the oscillator, and I could detect changes in pitch. And you move it like 8 inches away, and you could really detect pitch. And what was really interesting is that, I thought, well, maybe that's hand capacitance that's adjusting the pitch of this oscillator. But what was cool is that you could take and rotate the magnet 90 degrees, and the pitch would change with rotation. And my hand didn't get any closer to the oscillator, so it wasn't hand capacitance. It was definitely the amount of flux going through that coil. All kinds of stuff happening there. There's even weirder stuff, but I just can't even talk about it here. So how about your laser experiment there, Bill? M0HPR, KL7R.
Oh man, KL7R, M0HPR. Yeah, the magnets. I know those little magnets. We bought a few of them, and we had them around here, and they're great fun to play with. They're so powerful that you got to keep them away from your eyes. It's interesting, and the reason you do is because any of us who've been doing any kind of metal work, you might have a little bit of metal filing that flew up from the drill or the lathe, and if you've got any of that stuff in or around your eyes, you don't want to get that magnet near your eyeball. So that might be an urban legend. That might be something that has to be checked out by MythBusters, but it makes sense to me. So we keep those magnets far from the from the eyeballs there. But wow, and you are a true radio amateur. Anybody who has gone fishing for crescent wrenches in a bilge using magnets, Mike, you are marking yourself as a true radio amateur, I guess, or a true gadgeteer, I guess would be the way to put it. Our laser experiments. Billy and I, well, especially Billy, has been really interested in lasers for a long time, and we've been doing all kinds of laser experiments. And we use just the little pointer lasers that the guys use when they're given a PowerPoint demonstration or something. And we've picked up several of these things, usually at the Kempton Park ham radio rally that I go to. And we picked up this book a while back called Gonzo Gadgets. I think that's what it is. Is that what? Gonzo Gizmos. Thank you, Billy. Yeah. And the guy, it's a great book. We've recommended it. I've got the ad for it up on the websites. And in it, he talks about simple ways to make laser communication devices. And what prompted me to think about this, Mike, was that you, a few episodes back, mentioned how some students, or one of the books you were looking at, referenced the fact that if you needed to move a large amount of data, that they just casually mentioned that, well, you could try this way or you could try that way, and if that doesn't work, well, just build yourself a laser link. And so that got us thinking about the possibility of building a voice laser link. And sure enough, right about that time, the Gonzo Gizmos book arrived, and in it, he's got a number of really good, simple circuits for building voice laser communication links. And really, all he did was you take this laser, this kind of laser pointer, and he uses a little like transistor-size audio transformer, and he puts I think it's the secondary. It doesn't matter, but one of the coils goes between one of the terminals of the battery in the laser pointer and the laser pointer, and then you put your audio in on the other coil of the transformer. You're basically using that little transistor radio transformer, the audio transformer, as the modulation transformer in an AM radio. And so it's far from big iron. It's small iron. And then you just hook up an audio source to the usually what they recommended using was the audio coming out of a broadcast band receiver, and that's what we did. We used the audio from our favorite AM radio station, the Indian station here that we've been listening to on the Crystal Radio. And anyway, in it went, and Radio Kismet, 10:35 a.m. in London. Anyway, we took Radio Kismet's audio output, put it through the transformer, and modulated the output of the laser pointer. That's the transmit side. Now, the ingenious part is the receive side. He recommended using just a little photocell, diode, I guess similar to the diode in your VFO. There's a connection here, you see. Anyway, and using that as the receiver, and then he just said it was simply a matter of hooking up some high-Z headphones to put them across the diode, and that would be essentially give you the receiver. Well, we have these Volkswagen solar panels that I've been talking about from time to time. They're two little panels. I guess they're about 1 foot square, and they put them inside the windshields of new Volkswagens to keep the electronic system charged up during shipment. A lot of them are available on eBay and other places, and I have two of them here that I use usually to charge up my gel cell battery. Anyway, we pressed this thing into service. I literally pulled it off the window because it's attached to the window by suction cups, and we took the laser and pointed it at the thing, and I took the high-Z headphones from the Crystal Radio and put it across the output of the Volkswagen solar panel. And man, I'm telling you, audio is coming out of that thing clear as a bell. You could hear Radio Kismet coming at us across that laser link, and it was so cool because you put your hand there and break the laser beam, and the audio stops, and you remove your hand, and there's the audio. So even though it was only across the room, I guess I felt like Heinrich Hertz there, who did his experiments, the first radio transmissions. He only did it across the room too, but we were doing it across the room here with lasers. And yeah, I'm telling you, it was really cool. I don't know what band that would have us on. Somebody will have to do a calculation about what band we were on. But it was the light wave band, and it worked like a charm. KL7R M0HBR.
Yeah. So you just you put the headphones directly across did you put it through a capacitor, or did you put it directly across your solar panel?
It's directly across the solar panel. Now there's a diode in there too, because you always have a diode in the output of the solar panels to prevent the battery from reverse from draining through the panel. So there's always a capacitor in the lead of one of these solar panels. Anyway, I put them in there. But so we had, it's basically the solar panel, the blocking diode to the high Z headphones. But I suspect that the thing would work just fine if you just had the solar panel and the high Z headphones for the receiver. Go ahead.
Oh, so the diode is acting like a detector, and just driving the headphones. That's somebody's really sharp to come up with that. That's a good one. Well, you know what you could do? You could aim your laser across the street to a window, to your neighbor's window, and then make sure that the laser bounced back to your window and hit your solar panel, and by doing so, then you could detect the vibrations of the remote window, so you can hear people talking by the vibrations on their window. I wonder if that would work there, Bill.
I think you're getting carried away here, Mike. I've heard about that trick, but I think that, well, I think it would be tough using the technology that we have here. But well, you know, you mentioned about the diode. I think that it would work without the little blocking diode in there. I don't think that's an essential part of the circuit, because when you think about it, the solar panel itself is a collection of diodes. So I think that the solar panel itself would serve as a diode and do the detection for you. So it's a really, really simple transmitter and receiver. Now, in terms of going across the street, we thought about that because my kids have a really good friend, their age, lives right across the street in an apartment across the street, and we have a 400 megahertz walkie-talkie link from time to time, and we thought about the possibility of setting up two of these things and having full duplex, always on laser comms across the street. I guess one of the things that got me interested in ham radio as a kid was stories about how my uncles during the 1930s used to transmit Morse code messages by flashlight and telegraph key to friends in apartment blocks across the way in New York City. And I guess we've upgraded the technology here now. We're doing laser links. But hey, that brings us to a problem, and I want to ask the SolderSmoke community for advice and guidance on this. All of our laser pointers fail. I mean, they're all real cheap things. They're $4 or $5, and we get them, we play with them for a while, and then just as we're getting the experiments going, no more laser. And so I'm wondering, why is that? I notice it's not just us, because I was at a pretty high-powered kind of venture capital presentation on a guy who was selling new laser devices. They set up a big company, a startup, and they were selling a new laser. And the poor fella, he was using one of these cheapo pointers during his presentation, and the thing failed. Ouch. Of course, it had nothing to do with the laser that he was building, but it was kind of a bad moment there. And I sympathize with him, because we've gone through now 3 or 4 of these laser pointer things. I wonder if anybody out there can tell us why they're failing, and if they can recommend a better source for these kind of experimentations. We want to keep the power level really low so that we're not creating anything that's dangerous, and we're careful about where we point it, but you want to keep it so low that if you mess up, it's not going to hurt anybody. So we'd be looking for guidance there on possible laser sources here for continued laser communication experimentation. KL7R M0HBR.
Well, I've never had one fail other than the batteries. So, and I've had a lot of them fail due to batteries. But it takes, the ones I have like a number of little hearing aid batteries in them, and those things are more expensive than the whole laser to replace. Well, it could be something as simple as those lasers are basically LEDs, right? And if you overdrive an LED, if you don't have some sort of a current limiting resistor in there, the LEDs will burn up. Maybe it's the same sort of thing. Maybe just look in there and see if you can find if there's a current limiting resistor and add a little more resistance, or maybe you could. I don't know if this would work. I'd try that, or maybe add another diode or two voltage drop in there to see if that drops the voltage across them. I think it's more of a current thing than a voltage thing. So you might need some sort of voltage current limiting resistor. I wonder if that's what's going on. Well, guesses. Let's see what else has been going on here. I bought a TI calculator, and that thing's been in the mail for a number of weeks now. I hope it gets here. I had a couple of astronomical things I wanted to talk about. If you're ready to change subjects there, Bill, go ahead.
On to outer space. What's up, Mike?
Well, two things. I went and I tried to see Comet McNaught, McNaught, like Scottish nothing. I wondered, did you get a chance to see that? I went out and tried it, and we have such overcast here that the one day that it was a possibility, there was a cloud bank that moved in. A friend of mine saw it from here the day before, but wife and I had no luck. Did you get a chance to get out and see it?
It shows you how disconnected I am from things astronomical these days. I was unaware of it until I read about it in the local newspaper here, and they had a good picture of it over Chelsea in London, which is right where we live. So that I immediately scrambled to I use the Heavens Above website. It's a really good website. I think it's just do a Google search for Heavens Above, and you do a little registration process there. It's a wonderful website because it'll display for you the skies above your QTH. It'll tell you about visible satellites, the orbits of amateur radio satellites, and it'll give you the location of things like this new comet. And I checked, and I think I was looking at it on Wednesday or Thursday, and they said it was in the sky at that point. It was close to Venus, and Venus was already close to or below the horizon here in London, so I didn't get a chance to see it. And then we had clouds the following days. So I think based on my reading of the Evening Standard, which is not really the authoritative astronomical source, I think they said over the weekend it'll still be good and good through Monday. So I'm going to check the Heavens Above site and see if we can spot it. That'll be fun. And I'm hearing Maria. There she goes. Come here. Good morning. Say good morning to everybody. Say good morning. There we go. All right, that's Maria Patricia saying good morning to the SolderSmoke gang. Yeah, so what else on the astronomical front? KL7R, M0HBR.
Well, before you said, this has to do with Io, the moon of Jupiter. You said that you were looking through your telescope at Io and the moons of Jupiter, and mentioned Galileo, and mentioned your tracking program, and how there was a disconnect in the time that you expected to see the moons and the time that they showed up. And I just found out that Galileo thought there was a speed of light, and he went to measure the speed of light, and he sent a friend of his off a mile, and he opened a lampshade, and his friend was supposed to open his lampshade at the same time, and they were supposed to be able to detect the speed of light. Well, speed of light was way too fast for two guys in lampshade shutters, but what's really interested me, and I just found this out on a website. I got to get this website to you. I don't have it here, but it turns out that there's a guy named Reamer, R-O-E-M-E-R, only 70 years after Galileo, was looking at the moons of Jupiter, and he was recording the period of the moons of Jupiter going around, like Io and whatever, and he's getting these really accurate measurements of the time that the moons took to go around Jupiter, and he's collecting data over the course of years, and he noticed that at certain times in the year, the moons show up before they're supposed to, and at other times of the year, the moons show up later than they're supposed to. And he guessed 70 years after Galileo that the speed of light was involved. And so he calculated, based on how far he knew the Earth was from Jupiter, that the speed of light must be 186,000 miles per second. He got this thing within like 2% then. That's a hack. M0HBR KL7R.
Yeah, definitely. It's a wonderful story. And it's amazing what they did in very, very early days just by those kind of observations. Yeah, and I watched the. I can't do too much astronomy here from central London, but I can see the Galilean moons, and I think and I also I can see Saturn. Well, of course, I can see Saturn, the rings of Saturn, and I can see Titan almost all the time, and I can see one other moon of Saturn, Rhea. I can see when conditions are really good. And I was playing. I think there's a program called GalSat out there that will help you track the Galilean moons of Jupiter. And there's also one called, I think, Saturn satellites, and they'll track it. I think that what you're describing happened when I was looking at the satellites of Saturn. That they give you one display on the top of the screen where it shows you the actual positions of the satellite, and then down at the bottom of the screen they give you a projection of what it would look like through an astronomical inverting telescope on Earth, because the mirror flips everything around. And I was looking at the two things, and I was sort of progressing it by time period as to watch the moons go around, and I made the same. I guess with the computer, I made the same observation that Raymer made all those years back. That, well, wait a second, how come there's a time gap there? And suddenly it occurred to me that it was the speed of light. You can have fun, a lot of fun with these, even in really bad astronomical locations. One time I was looking at, about 2 years ago here in London, I was watching it was right around this time of year too, I was watching the Galilean moons as the sun was coming up over London. And so you could see all four of them there in the telescope field. And I was just curious about, and from looking at the program, I knew which one was which. And I watched progressively as one and the other, then the other, then the other became invisible. And I wanted to see which one was the last one to kind of go out of view as the sky brightened. And it was Ganymede. And I went and checked, and I think Ganymede is either the biggest of the four, or it has the brightest surface. But anyway, I was correct in figuring that, in observing anyway, that Ganymede was the brightest when viewed from Earth. So that was kind of not a discovery, but it's fun when you make an observation that you go back inside and you discover, hey, yeah, there's a reason for it. KL7R M0HBR.
All right. The site I wanted to mention is Physics 2000. If you do a Google search for Physics 2000, it's got a bunch of really cool stuff, and one of it was this thing on Ole Reamer and the speed of light. I read it 3 or 4 times. The more I thought about it, the more I thought that guy was smart. Just amazing. Speaking of the comet McNaught, if you go to spaceweather.com, they have a number of pictures of Comet McNaught. And one of the ladies at work mentioned, why does the tail point a different direction in all of the photographs taken in the morning versus the photographs taken in the evening. And I said, well, it's really not morning and evening. It's because they're days apart. But it turned out it's really morning and evening. Why would the tail be angled one way in the morning and angled the other way in the evening? Unless it just happened that all the people used an inverting lens in the morning and used a regular camera in the evening. I couldn't come up with a quick one for that unless that comet was really close to the Earth, such that the diameter of the Earth, you're the observer on the diameter of the Earth, would make that much of a difference. I was confused by that one. Maybe you can answer. Maybe somebody else can, or maybe it's just an artifact of people using inverting lenses, and all the guys were using one type of lens. I guess I could go back there and find one negative example, and that would prove it. What else, Bill? I got one other item. We could talk about RF probes if you want. Otherwise, we could leave that for another time. M0HBR, KL7R.
M0KL7R, M0HBR. Yeah, and we'll have to ask one of the comet experts to come in and let us know about that. The thing about comets is really cool is that if you find one, you get to name it. When I was in Dominican Republic, I was doing more astronomy than I'm doing now, and I used to take this little telescope that I had, and it was a 4.5-inch reflector, and take it out in the front yard, usually early in the morning and sometimes late in the evening. And my house, we had a night watchman, and a fellow named Antonio was out there, and it started out just by, I would say, hey, Antonio, take a look at this. And, he'd kind of amble over to the telescope and take a look, and man, he got hooked. And he became on his own, became a real kind of avid amateur astronomer there. And I told him, I said, look, he's got a good job for discovering comets, because through history there have been a number of guys who had similar jobs, sort of night watchmen, who, because they're out there all night, have discovered a number of comets. So I told him that there was if he kept his eye peeled, there's at least a remote possibility of there being a comet Antonio out there. I don't think he's made a discovery, but it was kind of fun that he got interested in it. RF probes. That's sort of what I wanted to talk about too a little bit. I've been doing some experiments with LT Spice, experimental methods, and what I've been playing with is related to the RF probe issue, and I've been designing in LT Spice simple, very simple feedback amplifiers. What I've been trying to do is pick the component values to come up with with gain figures and input impedance figures that I want. In other words, instead of just doing kind of cut and try, I start out with a piece of paper and say, okay, I want a common emitter amplifier that'll provide 10 dB gain with 50 ohm input impedance, and that will take me from 1 milliwatt to 10 milliwatts, something like that. And then I do the original design on paper. Next step is LT Spice. LT Spice lets me kind of play with the values and see if I'm in the ballpark. And then the third step involves actual solder melting. And Wes has been really great. He's been providing a lot of guidance and support as I fumble my way through this thing. So thanks to Wes for that. But and I know one of the issues is the measurement. How do you measure the power? And we've been discussing RF probes and whether more sophisticated measuring devices are needed as you get down into the milliwatt and microwatt levels. So tell us about RF probes, Mike. How low will they go?
Well, you made the comment that if the voltage across, if you're measuring an RF voltage that's less than 0.7 volts cut-in of a silicon diode, you can't measure anything. And I thought that wasn't right, so I went ahead and made my probe has a germanium diode on it. I don't know if I know that makes a difference between like 0.2 and 0.7 of a volt cut-in, but I had used my probe way below those voltage measurements, and I went ahead and created a calibration chart against my W7ZOI power meter, and for my probe, and the deal is it's not just cut in; it cuts in poorly, and there's a section of a diode voltage current graph that is basically curved, nonlinear, and then after the cut in, it becomes fairly linear. But you can still get measurements that are repeatable but nonlinear below the cut-in voltage, and I created a calibration chart for my 1N34 germanium diode 4.7 megohm resistor and 0.01 cap, the standard heat kit and handbook RF probe, and I took it clear down to insane low levels. I think I went clear down to like minus 20 dBm or something. Anyway, I put that calibration chart up on my website. I think it's under instrumentations and RF probe, and I also put an LT Spice simulation of an RF probe. It seems like that's way overkill, but basically I just wanted to show that there were still numbers you could get below the cut-in voltage that were repeatable, and so the probe extends well below that down into microwatt range, 10 microwatt. I think I got down some repeatable reading, but you have to calibrate your own probe. There's a 4.7 megohm resistor in the standard RF probe, and that's not an arbitrary resistor. That resistor is chosen to make it so that when you measure with your DC voltmeter that you're measuring directly RMS volts. A typical vacuum tube voltmeter had 11 megohm input impedance, and I went ahead and measured the input impedance of my Heathkit VTVM. That was 15 megohm input impedance. My scope was 10 megohm. My I had a B&K toolkit digital meter. That thing was almost 11 megohms, almost exactly 10.96 megohms, and the same with my Radio Shack multimeter. That was also 11 megs. So both of my digital voltmeters were 11 megohm. My Heathkit VTVM was 15 megs, and so that's pretty close. They produce results which are very close to the RMS voltage. The Heathkit was like 8% off from the two digital multimeters, and so if you have the RMS voltage, you can get power across 50 ohms or dBm across 50 ohms. And so anyway, on my website there's the calibration chart. There's the information and on how to build one. There's the spice model. That's what I wanted to say there, Bill. And if you want me to, I'll still offer to build you that W7ZOI meter. You just got to ask me there. M0HPR KL7R.
KL7R M0HPR. Well, thanks, Mike. That's a nice offer, but I don't want to add to your workbench woes there. And now that you've told me that the RF probe is good enough, then I'm good. See, because I have one. And I think the RF probe. I know we have a lot of listeners out there who are just getting started in home brewing, And I think that the simple RF probe is one of the most satisfying bits of homebrew test gear that you could make. I think I'm usually, I think I've told you this, I'm usually averse to building my own test gear. I don't mind building I like building my own radios. When I find myself building my own test gear, I start thinking, I've crossed the line here. I should be buying this stuff. But I don't think you can buy an RF probe. Maybe you can, but I've never heard of anybody buying one. And they're the kind of things that it's kind of fun. Mine is housed in a short length of PVC tube, and the actual probe is a discarded a probe from a discarded multimeter. And the guts of it, the resistors, the cap, and the diode are just in there, and the whole thing is held together with duct tape. And I've had a number of people in the shack look at it and say, "What's that?" And I'd say, "Well, that's my homebrew RF probe," and it provokes expressions of admiration from those poor unfortunate appliance-oriented operators who come in and they don't realize that it's a couple of resistors, a cap, and a diode. you get that kind of wizard feeling when you mention this thing. So I encourage people to build their own RF probes. Eventually, I might move up. I'm very slow to modernize my test gear here, Mike. So give me some time. I'll let you know about the W7ZOI probe. But thanks for that. And mentioning Wes, I think we're going to be able to post on the Gadgeteer site some of Wes's comments on my little feedback amp experimentation effort. Keep your eyes open on the Gadgeteer news website. I think we'll be able to put something up there. Thanks to Wes for taking the time to sort through my very amateur engineering efforts. And hey, speaking of W7ZOI, I understand that there was an actual electromagnetic contact on an important evening for radio amateurs. Was there a ZOI KL7R QSO, Mike? KL7R M0HBR.
Oh yeah, on straight key night of all nights. It was I'm tuning up and down the band, and I can't remember what I was talking on. Oh, I had that old. I was given a TS520 that didn't work right, and I didn't take much to get it working right. It just one of the crystals wasn't oscillating. And, anyway, got on there and I was straight keying away, and I'm tuning across, and there he is. He's got a pretty good fist. It's not as good as yours, Bill, but it's a really good fist. So you got a fist like a machine. I don't know where you learned that, but you got a good one there. But we chatted a minute. There happened to be a guy running a field straight key night brings out some really interesting CW signals. There's guys running chirps and whops and chow, pa-chow, pa-chow, chow, pa-chow. And anyway, one of those fellows happened to be right on Wes's frequency. So for some reason, everybody wanted to talk to this guy with this very interesting signal. Anyway, so he was QRM'd by people wanting to talk to this other fellow, but he got me a call, and we passed on a few things, and he was actually talking to a fellow across town from him, and I heard that fellow too. That guy had apparently was running a slinky loop inside of his house. So he was radiating with this slinky loop inside of his house. I assume the loop was in the roof of his ham shack room there. Anyway, nice talking to Wes. I talked to him twice before. I mentioned I talked to him once on 6 meters. He was running QRP on 6 meters. I happened to catch him there, and then I happened to catch him in a contest once on 15 meters. So both of those were memorable occasions. I think I did want to make one other comment about our probes there, Bill. There's a limit to, at least in the SPICE model, if you got over 25 or 30 volts, of RF that you were measuring with the RF probe, the germanium diode starts to flake and not give you. You still get readings. They're just not linear anymore. They don't match what you think they ought to be. They match pretty well between say 2 volts and 20 volts. What you read on the meter and what you'd guess below say a volt or so, germanium starts to become nonlinear. Still predictable, but nonlinear. So my question is, are you running a silicon diode on your RF probe or a germanium diode? And if you're measuring small signals, I'd recommend the germanium. Back to you there, Bill. M0HBR, KL7R.
KL7R, M0HBR. I think I got germanium in there. It's been a while since I built the thing, and if not, I'm going to go and check. I think you got to watch out, because I think it's possible when working with large signals to burn out that diode, and that's really discouraging when you have to stop your project to repair your RF probe. Of course, it's really bad, because it's probably taken you a half hour or so to realize that it's not the piece of gear that you're working on that's dead. It's your RF probe. Oh man! And if it's made out of duct tape and PVC, you got to peel off all the duct tape, and you got to go in there and find the thing. And man, that's not a good day in homebrew land. But yeah, I think mine is germanium, and I think of course you're right. Germanium is the way to go. Hey, speaking of on-the-air contacts, I just wanted to make a brief plug for 17 meters during the daytime. It's my favorite band, and I'd given up on it as we approached solar minimum. But I think a comment on QRPL was what got me back on that band, and I'm now running my little 5 watt SSB transmitter with the Drake 2B receiver and the vertical antenna. And the band is totally useless when the sun is down, but as soon as the sun gets up during the day, it's been really good. And I actually crossed the pond with the thing. I had a really solid contact. I think it was WB3ANT in Pennsylvania, and we had a real rag chew on 17 meters. And I work all kinds of Europeans and North African stations here. So 17 meters has been a real blast during the day, and it's just great to get on the air with the homebrew SSB rig and the Drake 2B. I've been having a lot of fun with it, so it's good to actually get out there and wiggle the ether a bit. And so I just wanted to mention that. Mike, do you think it's time to bang the gong?
Oh yeah, I'm starting to fade here, Bill. So one of my favorite movies. I think my favorite movie and my favorite actor of all time is James Coburn, and the movie is The President's Analyst. So with that reference, bang the gong there, Bill.
Welcome to SolderSmoke Mailbag. Hey, this is sort of related to the mailbag, but on a previous episode, I mentioned that we were developing a large following in China, and I noticed that on the SolderSmoke page, the statistics revealed that China was, I think, number 3 or 4 in terms of the number of hits. And so Mike and I were really delighted with this, and Mike actually made some comments in Mandarin, and I had visions of a large audience of SolderSmoke fans out there in China. I don't think it's happening. I took a look in more detail at the stats, and lots of hits, but no downloads. No, the download, the number of megabytes that are moving through to that location is minimal. I think 9 megs in the course of a year. I don't know why we're getting so many hits. Maybe people who know about this can let us know. Another indicator that it really wasn't happening is that we get no email from China. So it's a bit of a mystery there. We'd like to have listeners from China, but I have to make a correction there in this mailbag segment and say I really don't think it's happening. Now, an actual mailbag entry here. When I mentioned this business about the countries that are kind of making use of SolderSmoke, Phil, GU0SUP, on the Isle of Guernsey in the Channel Islands, came in and made a suggestion and asked whether our statistics, our webpage statistics, would be able to confirm DXCC in terms of downloads for SolderSmoke. I've never heard of this before. I think Phil might have invented something new here, but DXCC via download statistics, via webpage statistics. I did a quick count, Phil. We're not quite there yet. We're at 72 countries. 72 countries on the webpage stats. So we've got a ways to go before SolderSmoke wins DXCC via the internet. Thanks to the mail from Phil there. Also, kind of on the international front, John ON5EX writes in and says that he enjoys SolderSmoke, and he asks if we could maybe slow down and speak a little bit more clearly for our growing international audience. We'll give it a shot, John, but I can't make any promises. It's early in the morning, and plus we get into the technical stuff, and we try to keep the slang level down. We'll try, but again, I don't know how well we're going to succeed in that area. But thanks for the email, and we're delighted that people around the world are struggling to understand us. Wayne, VA7AT, sent in some nice email with some LT Spice models of DSP transceivers that he's been working on. It's always good to hear that there are other people out there working on DSB, and that leads to mention of a really interesting email from David M0DAD, who has built and has put on the air a double sideband rig transceiver for 40 meters. The amazing thing is that he worked another station, and the other station commented that he had previously worked a station with a DSB rig, and that guy was operating from the Azores. Dun, dun, dun. Who would that be, Mike? It had to be me. I know he had worked CU2JL, and that was me when I was out in the Azores. I guarantee you I was the only station running double sideband from Charlie Uniform 2 land. Kent, VE4KEH, just sent us an email this morning with some really good web links to articles about why and how antennas radiate, and I'll put them up on the Gadgeteer news website. Paul, M1CNK, sent a really good picture sort of related to the Can You Spot Your Antenna Through Google Earth segment that we did. He's using a system from Microsoft called local.live, and it provides really high-res pictures. And he sent us a shot of his house with a picture of his Yagi array up there. Very interesting. Kent, K4AHU, sent us a nice email. Thanks, Kent. Bob, KD4EBM, came in with some suggestions on how I could put my much maligned Radio Shack Model 100 computer online. He points out that my version of it was the smaller kind of laptop version of what I think is referred to as the TRS-80 or the Trash 80, and that my version is not prone to the RFI problems that Mike mentioned. I checked it out, Mike, too. I put it on and tuned around, and the thing is pretty quiet, so we might put that to work. John, KG9DK, is studying experimental methods for RF design and getting a lot out of it. And finally, this is related to the gong, Jerry, Alpha Alpha 6 Kilo India, listening from the Sonoran Desert. What a great location to be listening from. Sounds like a wonderful location for ham radio. Jerry was concerned about the fact that from time to time my children steal the gong, and we have to resort to the rather pathetic, lampshade kind of sound device. So Jerry has provided us with a digitized gong. So even if the kids take the real gong, Jerry has provided us with a digitized version that will always be with us. I told Jerry that we're kind of averse to using it. We like to use the real thing. When the BBC World Service plays Big Ben, That's from an actual microphone. No digitized wave files of Big Ben for the Beeb, and we're kind of following in that tradition. But it's nice to know that we have the digitized gong provided by Jerry, and we will use it if the gong, as happens from time to time, disappears from the ham shack. So that's a long SolderSmoke mailbag, Mike. Oh, one other thing I wanted to mention. This is not really a mail, but the GQRP Club is coming out with a new SPRAT CD. How good! That is good news for fans of SPRAT and GQRP Club. They're going to have all the issues on there on one CD. What a tremendous resource! And Tony Fishpool is running a competition for the artwork, for the CD artwork. So if we have any artists out there that want to make their mark on ham radio, get in touch with Tony. And there's a competition for artwork for the new SPRAT CD, for the sticker that goes on the actual CD. I think that's a really interesting project. Well, that wraps up SolderSmoke mailbag. Hey, Mike, I wanted to ask you: did the Fool's Gold, did the iron pyrite make it to Alaska, or was it intercepted by Homeland Security? KL7R M0HBR.
Well, it hasn't made it to Juneau yet, but that's a long ways. Like I say, I ordered my calculator, and it took them. It's been in transit for 3 weeks, so I wouldn't give up just yet. It hasn't made it yet, so. And if it doesn't, I'll make an effort this summer to gather my own from local grown quartz outcroppings here. I'm going to be gone next week, so maybe I'll catch you around the first there, Bill. I'm going to head out of town, and I'll try and I'm planning to bring a recorder, so maybe I can give a little 5 minutes of a SolderSmoke remote there from vacation there, Bill. M0HBR, nice talking to you, and have a good morning there to your kids, KL7R.
Okay, Mike, good one. Yeah, well, we'll see you then. We'll see you in about 2 weeks. Great. Yeah, send us a segment from the road and wherever you are, and we'll include that in the next one. Really good. Always great to hear about your projects and good to catch up. So I'll say 7-3s to you and 7-3s to the community of SolderSmoke listeners. I don't think we've ever mentioned this, but we calculate that there's about 1,000 of you out there. So this is a 1,000 person round table. So that's why I always say, okay, Mike, KL7R and the 1,000 person group, 7-3 from M0HBR.